what's important about today's lesson is we're going to talk about laws of exponents and different rules that apply when using exponents. And y'all learned about exponents before. In past years, y'all learned what an exponent is and what it does. So what is our exponent here? 3. That 3, and what does that 3 mean? So what is y to the power of 3? Y times y. Exactly. So that y is being multiplied by itself 3 times. Does that 3 go with the y or the x and the y together? That was kind of tricky. If it was x and y together, it would look like this in parentheses. That 3 only applies to the y. Because order of operations says you do exponents before multiplication, and how this is written is really x times y to the power of 3. Or again, the 3 only applies to that y, and then we multiply it. All right, so what we're going to do is expand this out. By expanding it, we're going to break it down into all the pieces. So just like you said, y to the power of 3 is y times y times y. So that's the long way of writing this. X times y times y times y. It means the exact same thing. And this is going to help us to understand some of these more complicated problems of how to simplify. All right, so this next one would be 3 times, how can I expand it out?
3 times x,
X
times x
times another x
times y times.
Exactly. So there's 3 z's, 1 y, 2 x's, and that 3 at the beginning. So that exponent represents how many times it's being multiplied by itself. And after a while, you'll see it's going to get kind of obnoxious to expand it. But the whole point is eventually to simplify it, and I'll show you a trick with that. All right, so there's a couple ways to do this next one. 2x to the power of 5. We can write it, that whole thing, that whole product 2x is being raised to the power of 5. So we can write it as 2x times 2x, total of 5, 2x's. Multiply together. So one way of writing it out. Another way I could have written this is to separate the 2 and x, to write 2 times x times 2 times x times 2 times x. Again, it is long. So that point, I will show you that shortcut too. So this will just make sense of how it works. You don't have to write this down, but another way we could do this is by rearranging. I'm going to put the 2's first. So there's 5 2's and then 5 x's. And the reason this is okay is because it doesn't matter the order you multiply. 3 times 4 is the same as 4 times 3. But this way I can see how many 2's do I have? 5. So I could write this also as 2 to the power of 5. And how many x's do I have? 5. So I can also write that as x to the power of 5. That 5 is being applied to both the 2 and the x. Now that 2 to the power of 5 we can solve by doing 2 times 2 is 4, times 2 is 8, times another 2 is 16, times that's the 2 of 32. So the shortened version of this is 32 times x to the power of 5. But these are the expanded versions written all the way out. All right, so this next section, we're going to rewrite. They're already expanded. We're going to rewrite them in the simplest form, which is the main concept of today. All right, so we have a -2, and then we have, how many x's? 4. So how would I write that?
X to
the power of 4. And then how would I write the y's? Y to the power of 2, or y squared. And that's it. This is simplified. You got it. All right, this next one, there are a couple ways to do this. Because they're identical, I could write it another way. I could write it 4x squared as my base, raised to the power of what? 4, because there's 4 of them. But I am going to show you another way, because this isn't fully simplified yet. I'm going to expand it and then resimplify it. So again, this is a little obnoxious. I'm going to do 4 times x, breaking it down, and do that 4 times. Times 4 times x times x, times 4 times x times x. Okay, so we have it all expanded out. I could rewrite it with all my 4's together, and then my x's, but I'm not going to do that. How many 4's do I have? 4. So how can I write that? 4
4 to the
4 to
power
the
of 4.
power. 4 to the power of 4. And then how many x's do I have?
8.
8. So x to the power of 8. Now at 4 to the power of 4, we can go ahead and solve by doing 4 times 4, 16, times 4 again, times another 4. And you are all
5, 6.
Yep, 256. 256 times x to the power of 8. All right, y'all try the next one. All right, how can we write this next one? X to the power of 3. Y. C to the power of 3. The power of 3 you can also call cubed. And notice I don't have those dots there for multiplication. It cleans it up. When they're side by side like that, it means multiplication. If you have the dots, that's okay, but typically it's written without those multiplication symbols. They're written side by side. All right, so now we're going to see what happens in these first three examples down here. There's multiplication taking place. So what we're going to do to discover what's really happening with these exponents is we're going to expand it first before we put it in the simplest form. All right, so how can I write x squared expanded? X times x. What about x cubed?
X
X
times
X.
Yep, and I'm going to multiply them together. So here's our x squared. Here's our x cubed. So together, how many x's is being multiplied together? 5. So how do I write my answer?
X.
X to the power of 5.
Beautiful. X to the power of 5. All right, so this next one, same thing. I'm going to expand it first, and then I'm going to get it, condense it, simplify it together. So I can rewrite 5x as 5 times x, and then I have a times 2, and then I have 3 x's. X times x times x, and then 2 y times y. Now I could reorder this and do 5 times 2, and then put times x times x times x times y times y. I'm not going to do that for the sake of time. But I can go ahead and combine 5 times 2, which will give me
7.
So 5 times 2,
Oh,
10. This one will give me 10. So this time I'm not adding those, but there will be some addition happening soon. How many x's do I have? 4. 4. So how do I write that?
10 x to the power
X to the power of 4. And how many y's?
y squared.
2, so y squared. So here is our most simplified form of that original. So one question that's come up in my classes today is to solve these. To solve for a variable, we would need an equation with an equal sign. So these are expressions. We could just simplify, rewrite them, but there's no like solving of what the variables represent. All right, so this next one, I'm going to rewrite this. This is the same thing as being multiplication. 3m squared and 5 times 3m to the power of 5 m squared. So to expand it all out, 3 times m, and then 5 n's. So the expansion isn't the most, it's not the best way of solving this. I'll show you a shortcut really soon. But it helps us to explain why it works. All right, so let's combine the 3's. 3 is being multiplied to 3, which would give me 9. How many m's do I have? 7. 1, 2, 3, 4, 5, 6, 7. So I would write that as m to the power of 7. How many n's do I have? Also 7. N to the power of 7. So here is my simplified expression. Okay, is there any shortcut where we could go from our original expression to our simplified expression without expanding it? What can we do? There's a rule where if you multiply, it's pretty much just adding the exponent. Exactly, we're adding the exponents. So if you saw here, we have our first example, the exponent of 2 and 3, and 2 plus 3 is 5. Here we had 1x. 1 plus 3 is 4. Then we have the 2 y's. But the 5 and the 2 are not exponents, so we multiply those like normal. Here we had m with a 2 and an m with a 5 add together to get 7. N had a 5 and a 2 added together to get 7. The 3's are still multiplied because they're not exponents. In fact, their exponents are 1. Because there's 1, so it's like 3 squared. 1 plus 1 is 2, so 3 squared 9. So what these are called, this is called the product property. And that's where when you're multiplying products together, a product is a number with an exponent. This is a product. 5 itself is the exponent, but that whole thing's a product. And when you multiply products, you really have to add those exponents. All right, this handout right here, the key is on Canvas to this side, and it's the definitions. It's basically those rules. On the star chart, it's called properties of exponents. And the first one there says product of powers or the product property. So product of powers. Product means that multiplication. And what this star chart says is A, to represent a number, a base value, raised to the power of m, times A again, meaning it has to have that same base value, raised to the power of n, a different exponent. What we would do is we'd end up getting that same base value, but we have to add those exponents together. So for multiplication, multiplying powers, as long as it's the same base, you're going to add the exponents. Same base, add exponents. So let's put a couple of examples over here on the side. I'm going to do 3x squared times 4x to the power of 5. What's the exponent with my x going to be here? 7, because 2 plus 5 is 7. But what about that coefficient, the number
12.
12, because I multiplied that like normal because it doesn't have an exponent. So 3 times 4 is 12. It's just that exponent. This comes from 2 plus 5. All right, another example. AB squared times A squared B cubed equals. What would the exponent with our A be? 3, because if there's not an exponent, it's an understood 1. And what would the exponent for B be?
5.
5. Good, because that's the 1 plus 2, and this was 2 plus 3. All right, back to our note page here. We're going to do this next row that are all fractions. This is going to be what's called the quotient property. Because we're dividing now. And we're looking for what our final answer to that division problem is. Quotient property. All right, so again, I'm going to explain this one by expanding it out, but then I'll show you a shortcut so you don't have to do the expansion. So let's expand x cubed. So what would that be? Yep. X times itself 3 times. And then x squared on the bottom, x times x. Now, when we have a fraction, don't write this down, but if we had, let's say, 12 eighths, what should I do with that fraction to simplify? I could divide by, what can I simplify by? 4. I can simplify by 4 to get 3 halves. So that's essentially what we're doing here. We're simplifying this fraction. Well, to simplify it, I could divide both the top and the bottom by an x. A number divided by itself is 1, so it doesn't change anything here. But then there's another factor of x in here. So I'm dividing by x on top and the bottom. It cancels out, leaving me simplified with just 1x on the top. That's 1. So x to the power of 1, or we could just call that x as our answer. Yeah, that'll be our shortcut we get to in just a second. 1. Okay, to make sense of this using that 12 and 8 example, remember prime factorization, which is what prime factors multiply to get that value. 12 is 2 times 2 times 2. I'm sorry, 2 times 2 times 3 gives you 12. Because 2 times 2 is 4 times 3. And 8 is 2 times 2 times 2. how simplifying fractions really work is we divide a factor that they share. So we can simplify by 2. That cancels out one set of those 2s, leaving me, essentially, if I simplify this by 2, I get 6/4. But I could also simplify by another 2, leaving me with that 3/2. That's what I did over here. I divided by x on both the top and the bottom to simplify that fraction. I divided by what factors they share to simplify. All right, so moving on to this next one, I'm going to expand it out. And I have 3 times n to the power of 4. So 3 times n times n times n over 3 times n. What can I simplify here? A 3, because 3 divided by 3 is 1. So that would simplify and cancel out. And what else can I simplify? 1n. So an n divided by n, they cancel out. And I'm left with 2 n's, which I could write as what? N to the third. N to the power of 2 n squared. Because I'm left with 2. Because I canceled 1. I'm missing an n. Oh, y'all, my bad. Thank you. Either I was making sure you're paying attention or I'm human. 1. I am missing an n, my bad. That does make a difference. So yes, I am left with let me undo that. Just cancel 1 n out. I am left with 3 n's. My bad. I missed something. So n to the power of 3. Right? Alright, expanding this one. It's going to be 4 times n times m times m times m times n times n times n times p times p times p. All over 8 times m times m times n times n times p times p times p times p. Okay, so expand it out. Again, I'll show you a way where we don't have to do that because yes, it takes time. What can I simplify here?
The m.
Okay, so I can simplify one group of m's and another group of m's. What else can I simplify?
2
N, 2 groups of n's,
and 3 p's.
and 3 groups of p's. 1, 2, 3. Anything else I can simplify?
Yes.
The 4 and 8. What does the 4 and the 8 simplify to?
Oh, 1/2.
1/2. Now I'm going to circle what's left over. Just to help me out. I have 2 m's on the top and an n on the top. On the bottom, I have my 2 and I have a p. So I can rewrite this as on the top of my fraction, in the numerator, I have a 1, and I have 2 m's, which I can write as m squared, and I have an n. And on the bottom, the denominator of my fraction, I have a 2 and a p. Now, simplified version, typically that 1 isn't there. It means the same thing about that one. And this is the simplified version of that. M squared n divided by 2.
Oh, it stands up.
This one does stay as a fraction because I have, just like I had before, 12/8 can stay as 3/2. Sometimes it simplifies to a whole number, and sometimes it simplifies still to a fraction. Okay, so that was the expanded version and simplifying. Any shortcuts we could do so we don't have to list it all out. Go straight from our original expression to simplified. What do you think?
Subtracting the exponents on the.
Exactly. We're going to subtract those exponents from numerator to denominator. 3 minus 2
1.
is 1. This is x to the power of 1. Here we have an exponent of 4, and this is like an exponent of 1. 4 minus 1, we got our 3. Here, the 4/8 simplifies to 1/2, but the exponents on the end, so if I subtract 4 minus 2, I got 2. For my n, 3 minus 2, I got 1. But the p's, notice it was 3 minus 4. What would 3 minus 4 give me?
-1.
-1, which we're kind of go more in depth tomorrow. But that's part of the reason why the p's at the bottom, because there's more p's on the bottom than on the top. Okay, the quotient property, also called quotient of powers on your star chart, states that a base raised to the power of m divided by that same base raised to the power of n would equal that same base to the power of n minus n, meaning as long as they're the same base, if we're dividing, we're going to subtract those exponents. Some examples here I'm going to do 12 times x to the power of 5 divided by 8 times x to x squared. All right, 12, 8 simplifies what? That 3 halves. And then what's my x going to be? What exponent will x have? 3, because I subtract. Now I could write this as even 1.5 times x cubed, or I could write this as 3x cubed divided by 2. They all mean the same. But yeah, you could write 3 halves x cubed. All right, and then another example I have for you is a to the power of 4, b to the power of 6 divided by a b squared. All right, what's the exponent that goes with our a and b? 3, because it's 4 minus the 1. And what about the exponent with the b? 4, because it's 6 minus the 2. All right, this last section is the power of a power. There's a few ways we could expand this first. I could write this as x cubed times itself 4 times. Because that whole product inside that parentheses or that power is being raised to the power of 4. Or I could expand it even further by saying x times 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 x. So how many total x's will there be? 12. 12. And we'll get to the shortcut real soon. You might see it already. All right, this next one we can write as, we can expand it as 2b times 2b times 2b, or I could expand it further, 2 times b times 2 times b times 2 times b. I could put my 2's together, 2 to the power of 3 times b to the power of 3. But 2 cubed, 2 times 2 times 2 would give us 8. And then b to the power of. So really both the 2 and the b are given that exponent of 3. This last one here, I could write 5b squared c cubed d to the power of 4 times 5b squared c to the power of 3 d to the power of 4. And then from there, I can use what we already learned about the product property. Or just for sake of understanding, I'm going to split it up, expand it even more, but you don't have to expand it any further if you don't want to. 5 times b times b times c times c times c. 40s all over again. All right, 5 times that 5 would give me what? 25. Common misconception is a lot of people want to do 5 times 2 to get 10, but the 5 is being squared also. That 5 is being squared. All right, how many b's am I going to have? 4. How many c's will there be? 6. 3 and 3. And how many d's will there be? 8. 4 and 4, or I can count all 4. And this is my simplified version. So anybody see the shortcut here? Right, so the shortcut is multiplying the exponents. So in this first example, it was 3 times 4 gave us 12. Here it was just 1 times 3, say 3. But the 2 was still being raised to the power of 3 because it was to the power of 1 times raised to that exponent 3. 5 squared 25, but 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. And last thing, let's write this down on this sheet right here. The power of the power, what it says on the star chart, is a to the power of n raised to the power of n equals a to the power of n, or n times n, where we're going to multiply exponents. Couple examples real quick would be 4 times x to the fifth power squared would be what? What's 4 squared? 16. And what's x to the power of 5 squared going to be? X to the power of 10, because really I multiply the 5 x here. And then let's do a b to the power of 3 to the power of 6. What would a's power be? 6, and what would b's power be? 8. Alright, that concludes our lesson today. There's practice for you to do. Don't forget to like and subscribe to my channel.